In this video, we'll be going over how to detect collisions between multiple physics imposters. We'll take a look at how to modify mesh objects when they come in contact with each other along with their materials. Afterward, we'll dive into using trigger zones with mesh intersections. So let's get started. Let's take a look at our starting scene. So in here we have a couple of objects which have imposters. This cube, this sphere, and the plane here all have imposters that allows us to interact with these objects using physics. We're going to be going over how to detect collisions and also utilize trigger zones. So let's jump into our code and let's get started. Okay, so here we are in Visual Studio Code. Once again, I'm using the Cannon physics engine for this. We have a class here called collisions triggers. Everything that we're working with in this class that we're starting off with can be found in a file called physicsdemo.ts. Again, that's in the snippets folder, and you will find a link to this code repository in the description down below. At the very top of this class, I have a couple of new references. So a lot of this is very similar to what we looked at before in a previous video. The only difference here now is I'm making a reference to the sphere, box, and ground abstract meshes because we are going to be using these in a couple of separate methods. Again, we are creating the imposter, so similar logic to before. And really the only main difference in here is that I did modify the position of some of these objects. I'm no longer rotating the box. I set the position down to 3. And then for the sphere, I adjusted the position up to 8 along the y-axis. You will also notice that I use friction for these. So some of these have friction, some of them don't. Friction will allow us to, adjust the friction of these objects so it can slide around a bit more. Okay, so with that said, I want to be able to detect a collision between these different objects. There are different ways of approaching this. We're going to start off with the very basics of just registering a collision detection between the sphere and the box that we created up above. I'll do this with the box. So with the box, I want to register a physics collision whenever we detect just the sphere. Then we'll take a look at how we can modify this to detect multiple objects. I'll do this in the same method where we're creating the imposters. At the very bottom, we're going to say this.box. And we need to use the physics imposter for this. So you can't use this with anything else unless it has a physics imposter. So I'm going to say dot register on PhysicsCollide. And if we take a look at this, you can see we need to provide a collide, and it says collide against. So this is the object that we're checking to see whether or not we actually hit it. So we're checking to see if this box hit this object. The object that we're looking for is the sphere's physics imposter. I'll say this sphere.physics imposter. And now we can either pass in a single physics imposter or multiple through an array. We'll be taking a look at using the array later on. Next, we need to provide a function. Now, one thing I do want to make note of, you do not want to pass in an arrow function like this. While you can technically use this, it's not really the proper way to use this if you want to unregister a function later on. So if you have an arrow function, that function is now tied to this. I can't unregister that same function because it's all included in here. So we're going to be creating a separate function for this, and we're going to unregister it later on. So right outside of the create imposters, let's create a new method. So this method will be called detect collisions, and it's not going to return anything. And we need to provide a couple of parameters for this. If I take a look at the registerOnPhysicsCollide, the function that we can pass in needs a collider and a collided against, which are both physics imposters, and the return type is void. So let's make sure that we match that up. I'll be using the collider and the collided against. I can name these whatever I want, but they do need to have a physics imposter as the type. So the collider, just to make things a little bit easier to understand what these are, the collider is going to be the box. So I'm going to say box COL just so we know exactly what it is. And this will be a physics imposter. The second one is going to be what we collided against. Now I could use a sphere, but this could also be an array of imposters. So instead, I'm just going to say COL against. Okay, that's short for colliders against or whatever we collided against. Okay, this also needs to be a physics imposter. Now I can take this right here, this arrow function, and replace it with this .detect collisions. Okay, it's complaining because we have an empty method in here. I really don't like when it formats it in this way, so I'm just going to reformat this myself. I know it's going to reformat it again once I save, but just so it's a little bit easier to read, I'm going to move it up. Okay, now what we're doing here is we're saying whenever we have a collision between the box and the sphere in regards to the physics imposters, and they want to then register this method to be called whenever we have that collision. I then want to unregister this later on, and we'll take a look at how we can modify that in a moment. For now, let's just add in a couple new things in here. So what happens when we have this called? Whenever we have a collision, in this case, I want to scale the size of the box. And we can also do something with the sphere as well, but I'm just focused on the box for now. I want to adjust its scale. So down in the detect collisions, the way I would do that is by modifying the properties of box COL. Okay, so let's say box COL dot, and we're going to be looking for the object. So with this, the physics imposter has an object, and then from there, I want to access scaling. Scaling is a vector 3. So I want to adjust the vector 3, and I want to increase its scale up to 3 by 3 by 3. Okay, so whenever there's a collision, the box will then increase in size. There is going to be an issue with this in a moment, but let's just see how this works. So I'm going to go and save that. I don't need to call this because it's being registered with this guy right here. And that's being called in the create imposters. So we just need to make sure that the create imposters is being called. And now we can take a look at our scene. Okay, so once the sphere hits the box, you can see it does increase in scale. So it is much bigger, but you will notice that, well, it's going through the ground. And you can see also that the sphere also bounced off the middle portion of that cube. So once again, I'll refresh this, grows in size, and you can see it basically gets swallowed up by the box. And the reason why that happens is because we adjusted the scale of the mesh, the visible rendered portion of that mesh, but we didn't actually modify the collider of that object, the imposter. So we need to modify that as well. If you do modify the scale of the mesh, you need to ensure that the physics imposter is also matching that same scale. Let's go back to our code. Let's make a slight modification and see how this works. Okay, going back into our detect collisions, what I want to do now is I want to make sure that the scaling of the imposter has also been updated. I want to reference the physics imposter, so we're just going to say box COL dot set scaling updated. All we have to do here is call it. If we hover over this, it just says sets the updated scaling. So if we adjust the scaling of the mesh, we're also going to be setting the scaling to be updated so that the physics imposter knows that it needs to change in size, whatever that may be. Let's save this and let's give this a quick try. Okay, so when the sphere hits the box, you can see it increased the size of the box. And because we were so close to the ground, it actually pushed off the ground. Remember, we're adjusting the physics imposter scale as well. That's what allows us to detect the physics imposter of the plane. So it actually pushed off the ground. That's expected behavior. We should see the sphere come back down any moment now. It should bounce off the ground. But now we know that works. Okay, so let's take a look at modifying the sphere that was just bouncing off the ground just a moment ago. Let's take a look at how we can modify the material of that object. We can do something very similar in the detect collisions method. Okay, going back into our method for detect collisions, now we want to modify the COL against. In this case, I'm just checking for the sphere, but we can use this for an array of physics imposters as well. So what I'm going to do here is I'm going to create a new material. I'll call it red mat, which will be the red material. And this will be set to a new center material. And I'm going to provide a name of mat. And then we're going to add it to our scene. Then red mat dot diffuse color will be a color of red. So new color 3, and we'll set it to 1, 0, and 0. That is the red color. Okay, now what I want to do is take this guy, and I want to apply a new material to it. It's going to be slightly different in how we approach this. So this is a physics imposter. We need to access the material, which is actually attached to the abstract mesh of this object. Let's take a look at how we can modify that. I'll do that right below where we created the modifications for the box. I'm going to say COL against dot, again, object. But if you hover over object, this is a iPhysics enabled object. So if I try to access the material of this, it's going to say, hey, you can't do that. That doesn't exist. So what we need to do here is in parentheses, we need to essentially cast this as an abstract mesh. So we're basically using this as an abstract mesh again. Now I get access to the material. Okay. Again, if I leave this out, you will see that you will get an error. And I'm going to set the material equal to red matte. And then just so we can actually see the sphere, we don't want it flying up into the air. What I'm going to do is actually turn this off by commenting it out. We'll save this and let's see how this works. Okay, there you go. You can see right when it hit the box, we then modified the object that we're colliding against. So now this has a red material. Okay, so now we're going to take a look at how we can use a physics collision with the sphere. And this time we're going to be detecting both the box and the ground. And then we're also going to take a look at an example of how we can unregister these different methods that we're using. Let's take a look at our code. Okay, going back to our code, we're going to modify this a little bit. I'm going to be using the sphere this time. We're going to use the same logic as before, so we are going to be using the detect collisions. We're going to keep everything else as is here, but now we're going to be using an array of physics imposters for this. I'm going to comment this out. And what we're going to be doing now is we're going to use the ground. I want to change the material of both the ground and the box whenever we collide with it. So I need to make sure that I can actually see the ground. Right here where it says is visible, I'll just set that to true. And just so it's slightly above the ground, what I'm going to do here is say this.ground.position be a new vector 3. Man, actually, I can just set the y here. And I'll set this equal to 0.25, just so it's slightly above the ground and we don't have any kind of z fighting with the mesh. All right, let's take a look at this real quick. So down here, we're going to repeat this same process that we did for the box, but we're going to be using this with the sphere now. And now we're going to be using a physics imposter array. So this.sphere, physics imposter, .register. And we're going to use an array of imposters. So this.box.physicsImposter, this.ground.physicsImposter as well. After that, we pass in the this.detect collisions. Okay, we'll save that. Okay, now we can use the same logic as before in terms of changing the material. We're using a physics imposter for the COL against. I'm not using the box COL, so I'm not going to rename that. But with the COL against, I can then change the material every time we have a collision detection. Once we detect a box, we're then going to be changing that material. Once we detect the ground, we're also going to be changing that material as well. So we can use the exact same logic as before. Let's take a look at this in action. Okay, so that we can see the floor. You can see once it hit the box, it turns red. Once it hits the ground, it turns red as well. And you can get a little bit more advanced with this as well if you wanted to. You could say, well, if I hit the box, I want it to be a green material. If I hit the floor, I want it to be a red material, so on and so forth. But there you go. Now you have a very basic example of how to use this with an array of physics imposters. Okay, let's take a look at how we can unregister these collisions as well. Okay, going back to our code, let's take a look at how we can unregister the detect collisions. So what I'm going to do here is actually utilize just one object for this. So one physics imposter. So when we detect the box, I want to repeat the same process as before. We're going to add the red material just to the box. But now if I hit the ground, I want to unregister this. We're going to copy all this. And we're going to say this.sphere.physicsImposter.unregister on PhysicsCollide. So when we collide with a specific physics imposter, I then want to unregister detect collisions. But this time I want to use the ground for this. And we set this to be the box physics imposter for both of these. What's going to happen is that detect collisions will essentially never be called because this is based off a physics collision for both of these. Okay, so we're going to register and unregister at the exact same time, and that means that this will never be called. So keep that in mind. I'm using a different physics imposter up here versus the unregister. So again, if I hit the box, I then want to change the material using detect collisions. When I hit the ground, I'm then going to unregister that. We're not going to see any kind of logic being called at all. We're just unregistering this function. Now it is going to complain because we're not using an array for the physics imposter. Now you'll notice that if I do that and I say or physics imposter array, okay, now it's going to complain down here. So just to make things nice and easy, this is not ideal, but I'm just going to set this to any. Now I can use this for anything really. Okay, now it is going to complain because it doesn't want me doing that, but I'm going to leave that as is. All right, so let's take a look at how this works. Let's go back into our scene. Okay, so the box is going to turn red. Okay, and when it hits the ground, it no longer does anything else because we're not checking for that collision. But if that sphere were to then hit that box again, it's no longer going to do anything else because it has been unregistered. Okay, now let's take a look at one last thing, which is going to be using the triggers. Okay, so going back to our code, I'm going to take all this right here. I'm going to comment it out. And then let's also make sure that we set the ground back to invisible. So I'll set this to false. I'm no longer going to use the box for this. I'm just going to comment this out as well. I'll keep the ground and the sphere. Okay, and I don't have to worry about this. We're not even calling this anymore. I'll close this up. Now we're going to create a new method specifically for triggers. Now triggers in BabylonJS have nothing to do with physics really. All we're looking for is a mesh intersection. So we don't have to use any kind of physics engine with this. We're just checking between two different meshes, basically intersecting with each other. So let's create a method for this. I'll call it detect trigger. We're just going to have one, so we'll call it detect trigger. This will not return anything, so we'll set it to void. Okay, and for this, I'm going to be using a new box. We're going to create in here. This will just be a mesh object. And we're also going to be using our sphere from up here. So I want to check to see if our sphere has intersected with the box. Box mesh builder dot create box. I'll name it box. And for the size, I'm not going to be using that. I'm going to be using the width, height, and depth. So for the width, we'll set it equal to 4. The height, I'll set equal to 1. And the depth, we'll set it equal to 4 as well. I'll set the box above the ground. So I'm going to say box.position.y. I'll set that equal to 0.5. So a good rule of thumb for the position, if you want this to be above the ground, typically with BabylonJS, you'll see that a mesh object appears at the center point for the box. So you'll see that it's halfway through the ground. So whatever the height is, just divide that by 2, and that's what the position should be if you want it perfectly level with the ground. So box.position.y. Let's also modify the visibility of this mesh. So I want this to be slightly transparent so we know that it is a trigger. It's not just a regular mesh. So I'll say box.visibility, and visibility is a number. And for this, I'll set it quite low. Let's go down to 0.25. So this is kind of like adjusting the transparency of this object. Okay, we'll take a quick look at what we have so far. Let's make sure that we call this method. We'll do this in the constructor. So right below where we create the imposters. This dot detect trigger. Okay, so there is our trigger. We can clearly see that the sphere is going through it. So if we take a close look, you can see it does intersect with it. So with the trigger, that's what we're trying to detect. We're trying to detect if two meshes have intersected. With triggers, we're just going to be detecting one mesh object. In this case, that's going to be our sphere. Remember that triggers are typically things that would detect a single object like a character or something of that sort interacting with it. We're not detecting multiple objects at once. You can detect multiple objects with these triggers, but you're going to have to rewrite the mesh intersections for each single object. So let's take a look at how we can detect the sphere entering the trigger. Okay, going back into the detect trigger, let's take a look at using the box as the trigger zone. So I want to see if the box has intersected with another mesh. You can either do this on the box or the sphere, but typically I would do this on the actual trigger itself. So let's say box dot and type in intersect, and you should see intersects mesh. You'll also see intersects. Intersects refers to using a ray. We're using an abstract mesh for this. So box.intersects mesh, and we need to provide an abstract mesh or a solid particle. I'm going to say this.sphere. Okay, remember this.sphere is a abstract mesh. If you go up to the very top here, we're using this as an abstract mesh. We're not using physics for this. We do have some other options with intersects mesh. Precise in there will allow us to use this with a rotated object. If you have a ramp, for example, that you want to use as a trigger zone, you could use precise for that to better match. And then you also have include descendants. If you had a complex mesh that had children, you could use include descendants so we can detect an intersection with the children as well. But this is just a basic box. We're going to leave that as is. So I'm checking to see if the box intersects with the mesh that's been provided here, which is the sphere. Now, before we take a look at this on the front end, we're not done quite yet. This is a method if you hover over it, but it returns a Boolean. So this basically says, hey, we have intersected with this mesh or we have not. So what I want to do here is actually want to console out the result of this. I'll say console.log and I'll say intersects. This will then appear in our console.log. This will either be false or true. So let's save this. Okay, looking at our console, we can see that intersects is set to false. Even though that the sphere is intersecting with the mesh, the reason why this is happening is because whenever we created the method for detecting the trigger, intersects has been set to false by default because it was only called once. We need a way to constantly check whether or not something is intersecting with our trigger. So let's go back into our code and let's modify that so we can see when the sphere intersects and when it's not intersecting. Okay, so going back into our code, we're going to be using something from the scene. I can say this.scene.register before render. This is very similar to how we did this with the detect collisions, but this time I am going to be using a arrow function for this. I'm not going to unregister this. I just want to go over an example of how to set this up. So we're going to use an arrow function for this. And I'm going to pass this in here as the logic. So this is going to be called every frame. This is not something you would want to do very often, but we're checking every frame whether or not we've intersected with the sphere. So register before render happens multiple times per second, every frame. We're then going to see this toggle between false and true and vice versa. Okay, so when it's outside of the box, you can see it says false. When it's inside, it then says true. Okay, and as you can see here, you don't want to keep checking this over and over again, but this is just a simple example of how we can set this up. Okay, let's take a look at one last thing within the detect trigger. This will allow us to detect the trigger just once. So when we have the sphere enter the box, the very first time, I can then use that to play an audio clip, play an animation, whatever that may be. But I just want to detect this once and then call a function or whatever that may be just once. So an easy way to modify this is to use a counter. So let's add in a variable here. I'll call it counter. I'll default to 0 for the counter value. And here we're going to check if. And remember, this returns a true or false value. So I'm going to take this out. And I'll say, hey, if this is true, I then want to increment counter. So there are a few ways to do this. You can say plus plus, which I'll be using. You can also say plus equals 1. But plus plus will increment it by 1. And then down here, I'm going to change the console message to say entered trigger. And the way that I'll detect whether or not we've entered the trigger one time is to just say, hey, is the counter equal to 1? So if the counter is equal to 1, then we've entered the trigger. All right, let's see if this works in the console. Okay, there you go. You can see it only popped up once. Even though we have multiple intersections, it's only going to appear once. Okay, so there you go. Now you know how to set up collision detection and trigger zones inside of BabylonJS.